Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a topic whose name is Gibbs Phenomenon. Basically, what is Gibbs Phenomenon? In Gibbs Phenomenon, what we are going to study, a number of oscillations produced during reconstruction will be shifted towards either ends of the sequence or the graph. And this was first observed by Josiah Gibbs, who is a famous mathematician. That's why this phenomenon name is given as Gibbs phenomenon, and the oscillations produced during reconstruction is called as Gibbs oscillations. Now we will see what he said. First of all, we will write exponential Fourier series formula. This formula consists of infinite values of Fourier or frequency or harmonic components. When we are going to reconstruct this rectangular or square wave, or when we are going to regenerate this square wave, then you can see that first of all we convert it into Fourier domain and then we transfer it over the cycle or medium. Basically, this formula consists of nth number of different harmonic components. Now, these components, if we are going to reconstruct the signal, then all the components will be shifted towards both the sides of sample or the square wave. So, first of all, Gibbs phenomenon. We will write the definition of exponential form of Fourier series. This was the exponential form of Fourier series. Now, this form consists of nth number of or infinite number of harmonic components. Now, harmonic means what? The number of oscillations are produced during the reconstructions. And this is called the harmonics or unwanted signal, that is called as harmonics. Now, if we increase the nth terms or order of n, then what will happen? All the harmonics produced during reconstruction shifted to the either side of this pulse. And if we goes on increasing these n values, then all the harmonics or the oscillations shifted towards the right hand side and the left hand side of pulse. Then what will happen? If our n tends to infinity or upper capital N value is equal to infinity, then all the harmonics will be shifted towards the either end, and what output you can see? This type of output you will get when your n value tends to infinity. Now look at here. Here we have placed our n values. First of all, if I keep my n value is equals to 1, then you will get simple sine wave. But if we goes on increasing, so first of all, if I keep n equals to 1, then you will get a simple sine wave. But as soon as if you goes on increasing the n value, then you can see that we'll get some square wave shape. But the amplitudes of square wave is not constant. Some harmonics or some oscillations are there. And this was first seen by Josiah Gibbs, who is a famous mathematician. That's why this phenomenon is called as Gibbs phenomenon, and this oscillations produced during reconstruction is called as Gibbs oscillations. If the value of n goes on increasing, then whatever number of oscillations produced during reconstruction will be shifted towards the either side. So look at here. For n equals to 5, we have oscillations and the amplitude is not continuous, it is discontinuous. But now when n equals to 59, you can see that some of the amplitude is constant and all the oscillations shifted towards the either end. Now I can say that if I take n equals to 100, then your amplitude is more stable compared to 59. So if we want to obtain a constant amplitude, then you have to increase the value of n, and it will be maximum if you want to take to get the constant amplitude or the constant amplitude in reconstructed signals. So this is what we are going to study, or we have studied in Gibbs phenomenon. So thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.